Hello, my name is PJ Burke, and I chose to do the vortex cannon experiment at the beginning of Chapter 6. As you can see, I've built a homemade vortex cannon. I accomplished this by sealing a cardboard cereal box with tape and cutting a circular hole 5 centimeters in diameter in the center of one face. Now when I tap the other face, rings of air will shoot out of what I call the barrel of my vortex cannon. To demonstrate this, that air is indeed flying from the cannon, I've hung this piece of yarn from the ceiling. You can see that air from the cannon is going to cause the yarn to swing back and forth. When I hit the back of the vortex cannon, it sends a shot of air out of the cannon and it hits the yarn, causing it to move back and forth. Next, in order to see these rings of air directly, I will put some flour in a different cannon. I have that one set up here. Before I demonstrate with this cannon, however, I have some predictions. I think the powder will be swirling around the ring in some manner as opposed to stationary. I think that hitting the box lightly will create a larger but slower ring, while hitting it harder will create a smaller but faster ring. I think the ring's size and speed will decrease the longer it is in flight, because the air will spread out and become less concentrated as it leaves the vortex. All right, so let's see what happens. Alright, so that was a lighter hit. And I can see that the flour is swirling through the ring, which is one of my predictions that came true. I'm going to tap it lighter again, and we'll see if it'll create a larger, slower ring like I thought. And then versus a harder hit. It's difficult to see on the camera, but what I'm able to see in front of me is that when I hit it harder, the ring seems to go farther, but it seems about the same speed as when I hit it lighter. It's just that the lighter one goes straight down, whereas the harder hit seems to go out farther. So that's a little bit different than what I predicted, but I suppose it makes sense. Now, the longer it is in flight, regardless of the distance that it travels, it does dissipate. Next, I will cut a larger hole into this vortex cannon to see what impacts that has. Alright, now I have a larger hole cut, so we're going to repeat this experiment. The only thing that I'm noticing happening with that is the diameter of the ring appears to be getting larger, but it doesn't seem to be going any farther or any faster when it shoots out of the cannon. The purpose of conducting this experiment is to help understand airflow as a fluid. Water is easy to grasp because you see it in everyday situations all the time. But air is harder to visualize because we seldom see it in the real world. This experiment gives us a visualization of airflow as a fluid, giving us additional comprehension of this concept. The vortex cannon creates ring vortices, tiny tornadoes that are bent into loops and so have no beginnings or ends. Air swirls forward in the middle of each ring and backward on its outer edge. This circular tornado structure is created when air flows through the hole of the vortex cannon. Air flows forward in the middle of the hole, while the hole's edges create the backward flow around the outside of the ring. After it leaves the cannon, each ring's vortex crawls forward through the surrounding air until its kinetic energy has been exhausted and it slows to a stop. It finishes its existence swirling in place until viscous forces bring its moving air to rest. This is similar to the action of water moving down the drain, but thanks to this experiment, we can visualize the action for the fluid of air. Thank you very much.